Hello everyone, my name is Nana and today I will take you through my project 2 for design and manufacturing. I have titled it Clip-on Cable Holder. I will begin by explaining the problem, talking about my solution, the processes involved, and the benefits and the drawbacks. So what I decided to tackle in this project was how my cables always fall on the floor and I have to stretch down and reach them when I need to charge my phone. Now, there are a couple of solutions for this, and as you can see on Amazon, they have cable clips, cable catchers, cable holders, however you want to call them. I call them cable holders, and they essentially prevent your cable from falling down by blocking the head of the tip of the cable using various designs. I found that there are three categories of cable holders: magnetic, adhesive, and weighted. However, all these have some semblance of permanence. As for magnetic, you can only clip it onto a specific place, which is metallic. For adhesive, you have to set it and keep it there, and for weighted, it can only be on a flat surface. However, I often move between my bed and my desk, and so these solutions aren't really practical, as I would only want just one. So the current solutions lack a lot of versatility because I might move from my bed, as I mentioned, to my desk, and I would still want to be able to charge and have my cables held. So I decided to explore how I could get the benefits of the cable holder and have some versatility as well. The design prompt was to design a cable catcher that can be used anywhere and moved as many times as possible with ease. The design criterion seeks to take the traditional cable holder and apply versatility. I took inspiration from pegs and hair clippers, which you can essentially clip to anything. So I decided to look and see if there are any clip-on cable clips, which I call them. And looking through Amazon, I realized that there actually were not any designs which allow you to move your cable catcher around as many times as you want anywhere. So in my solution, here is a high level schematic. I have a dual cable slot system because I wanted to have more than one cable. And using the traditional design for a peg, I essentially attach the cable catcher to the peg. And I have teeth for gripping so that I can put it onto as many edges as I want to. Here is what the CAD looks like, and I'm going to explain a little bit more about it. So just to give you a breakdown, we have the slots as I mentioned before for the cables, the teeth which allow you to clip it onto any edge or surface, and the clipping press. You have the head, the tail, and the spring all connected by a spring pin as well. Here are some other views of the CAD. This space allows you to clip it onto edges which are relatively thick as well. Now to talk about the materials and the manufacturing. For the head and the tail, thermoplastic elastomer, otherwise known as TPE, or thermoplastic polyurethane, otherwise known as TPU, was chosen. This is because these materials have rubber-like texture and are soft and flexible. I would want it to have rubber-like texture because it would need to have grip on the edges, and as you saw, the diameter was slightly less than the opening at the top, and so it needs to be able to bend for the cables to be put in and out. For the spring, stainless steel would be used, but it'll use off-the-shelf parts, and for the spring pin as well. Now, in order to manufacture the head and the tail, injection molding would be used, and this video briefly talks about how injection molding works.
In principle, injection molding is simple. Melt plastic, inject it into a mold, let it cool, and then out pops a plastic product. In reality, injection molding is an intricate and complex process. An injection molding machine has three main parts: the injection unit, the mold, and the clamp. Plastic pellets in the hopper feed into the barrel of the injection unit. Inside the barrel, a screw transports the pellets forward. Heater bands wrapped around the barrel warm up the plastic pellets. As the pellets are moved forward by the screw, they gradually melt and are entirely molten by the time they reach the front of the barrel. Once enough molten plastic is in front of the screw, it rams forward like the plunger of a syringe. In a matter of seconds, the screw injects the molten plastic into the empty part of the mold called the cavity image. The plastic solidifies in under a minute. The mold opens and the part is ejected. The mold then closes and the process repeats.
So as you saw in the video, the head and the tail will needed to be made using molds. TPU also works very well with molding, and so this process would not be complex at all. Although they're not the main focus, I still wanted to talk about how wire coiling and rolling work as well. So as you can see in this video, it takes in a straight piece of string and then it passes it through a process which coils it up. So here's the straight wire that is going through this. There's also a couple of rolling and heat treatment processes that are used to make the pin. Now let's talk about the practicality of it all. For the advantages, the product is pretty portable. It's lightweight and can be moved around quickly. And this is useful when you just have one set of wires and you're moving from place to place, like in my case where I have the bed and the desk. It's easy to use. You can clip it onto any edge. It has a dual slot so you can take more cables, making it even better. And it has no residue like the adhesive version, which leaves like glue residue and marks. For the disadvantages, it may not hold larger cables securely because the diameter was picked for traditional phone charging cable. So if you have like a larger cable for like an industrial sized PC, that might not work. And it might not work for very thick frames as well if the frame is wider than the pegging distance. But these are very minor. So as you can see, there's a lot of use cases. You can clip it onto the arm of a chair. You can clip it onto the edge of a table. You can clip it onto your bed frame. This allows you to keep your charger cable in place on very different surfaces. So in conclusion, this solution solves my problem of having my cable fall on the floor each time and allows me to move in between my desk and my bed while still having the benefits of a cable catcher. Here are some sources that I used, and thank you for watching. This video was used for educational purposes only.